Assalamu alaikum wa rahmatullahi wa barakatuh. Our lesson today, computational fluid dynamic, another example of one-dimensional steady-state diffusion. First, I will read the example. In a conical fin of length 10 centimeter and base radius 0.46 is protruding from a wall as shown in figure. The base temperature is equal to 100 and the end is perfectly insulated. Mean when he say the end is perfectly insulated, he mean dt over dx is equal to 0. The fin is exposed to an ambient temperature equal to 25. If the thermal conductivity of the fin material is equal to 100 and the convection heat transfer coefficient is equal to 40, find the temperature distribution along this fin using the finite volume method. The one-dimensional steady-state energy equation for this problem is given as follows. He gave me the equation of the steady-state diffusion. When you see this equation, if you are confused between the steady or unsteady state diffusion, you can see that the time is not exist in this equation, so the equation is a steady state. If you find the time in the equation, so the equation is unsteady state. So in this equation we don't have time, so it's a steady state. He gave me the relation of m squared, so I will just apply the number inside it and I will get the m squared. First I will convert the unit into a meter and then I will apply the equation. As usual, we will find delta x is equal to the length of the fin over the number of node. Number of node, you can increase it or decrease it. It depends on you. If you increase it, you will have more accuracy to the distribution of temperature along the fin. The fin is from here. The fin is from this point to this point. He wants me to find the distribution of temperature on this region. You should know that. So the length of the fin is equal to 0.1 over the number of node. I choose it 5 on here. It's equal to 0.02. M squared is equal to 0.808. At the beginning we will as you see, I divided the length of this bar is equal to 0.1 is the length of the fin, 0.1. So at the beginning, from this point to this point is equal to delta x. Delta x is equal to 0.02, and from this point to this point it's equal to 0.04 because I add 0.02 to 0.02, I have 0.04. The same way I have 0.06 and 0.08. How to find the x point? I found x point by dividing delta x. The delta x is from here to here over 2. 0.02 dividing by 2, I got 0.01. By adding delta x to 0.01, I got the x point of node 2. And to get the number of the value of node 3, I add 0.02 to x point of node 2, and I got 0.05. The same way for node 5 and node 4. Now we will start to integrate. At the first, we will integrate at node 1. Node 1 is here. Node 1 from west to east, d over dx x squared. I will integrate the equation that he gave me. And by dividing on the area, ADX is the volume. By dividing A over A, I got x east and integrated from west to east. X east minus x west, x square is converting to x east, x west, minus m square x b t point t infinity dx. When I integrated it converted to delta x. Then when he tell me in the question dt over dx is equal to 0, because he tell me in the question that the end is perfectly insulated. It means that dt over dx is equal to 0. You always should get attention to these phrases. So I will just have x west squared. I forget here the negative sign. The negative sign, you should put on here the negative sign. X squared west, t point minus t west over delta x minus m square xp tp minus t infinity delta x equal to 0. Then I will separate the variable that it have t point at the left hand side and the other to the right hand side. Then I will write its equation. The equation is a point t point is equal to a west t west plus the source term plus 0 t east. T east, I don't have t east at node 1. So a east is equal to 0, a west is equal to x squared west over delta x. X and a point is equal to a west plus a east minus xp. When I substitute sp, its sign is negative, and the sign on here was negative. It convert to plus sign to positive sign. M square xp delta x. The sp is equal to minus source without its temperature, as the source is equal to m square xp delta x t infinity. It's here. So then I will integrate the node 2, 3, 4 from west to east. I will integrate it by dividing on area x square east minus x square west dt over dx west minus m square x x, and then I will substitute dt over dx for east minus t point over delta x minus x square west t point minus t west over delta x minus m square xp tp minus t infinity delta x. I will show you how dt over dx convert to this and how dt over dx is convert to this for the node 2, 3, 4. When we see the bar, we want to find the a west, a east for node 2, 3, and 4. For node 2 at east, we write t east minus t point over delta x and t point minus t west over delta x. I hope you understand what I say. Then I will continue the separate the variable. As usual, we will separate the variable that it have t point at the left hand side and the other at the right hand side, and then I will write its equation. A point t point equal to a east t east plus a west t west plus the source term. The source A west is equal to x square west over delta x. A east is equal to x square east over delta x. And A you should get attention to the sign, because on the SP has a negative sign when you substitute it on AP it convert to positive, because you multiply negative sign with negative sign. The source term is equal to m square xp delta x t infinity. Node of 5, I will integrate the last node is node 5 from west to east, d over dx x squared dt over dx a dx minus m squared x point t point minus t infinity a dx is equal to 0. By dividing it on the area, I got x east x square east dt over dx east minus x square west dt over dx west minus m square x p delta x t point minus t infinity is equal to 0. When you substitute dt over dx east is t east minus t point over delta x minus, I don't have at node 5x west because it's the end of the length of the bar, so it's convert to x at the base fin. X at the base fin. You should get attention to this point. And dt over dx will convert to t point minus t base temperature. I don't have t west, I have base temperature over delta x over 2. I have already explained why delta x over 2 minus m square xp delta x t point minus t infinity over. Then I will separate the variable that it have t point at the left hand side and the other variable at the right hand side, and I will write the equation of it. A point t point is equal to a east t east. I don't have t west, so it's equal to 0 plus I don't have a west, so it's equal to 0 plus the source term. This is a west. I don't have a this is a east. I don't have a west. This is source. All of this is the source term. So SB is equal to minus SU without its temperature. Then I will assemble the table that I have already got, and I will write it in one table, and I will substitute, and then I will substitute the number in the point. For example, node 1 a west is equal to x square west over delta x. A east is equal to 0. A point a west plus a east minus sp. Sp is equal to minus m square xp delta x. Su is equal to m square xp delta x t infinity. When I substitute the number, I will get this. X west is equal to 0. X west for node 1 is equal to 0.02. When it got to be squared, it's 0.004 over 0.002. It's converted to be 0.02. A east is equal to 0, and then I will find this term m square m square is equal to 0.808. Delta x is equal to 0.02, and the x point of the node 1 is equal to 0.01. T infinity, I will got SB. It's the same way as you can get the source, but multiply it by ambient temperature, which it is equal to 25. Then you will get this table, and we will then write the equation. The A points refer to the node point, mean A point mean T1 0.02016. T1 is equal to the east. What is the node that is at the west side of node 1? It's T2 plus the source term. The same way we can find node 2 is equal to what is the point that is at the west of node 2? It's node 3. What is the point that is at east side? Is T1 of node 2. It's T1 plus the source. What is the west of T3? Is T4. What is the east of T3? It's 2. You can know it from the bar that you have divided already. Means this is the bar, this is the bar. At node 2, what is the node that is at the right? It's node 1. What is the node that is at west? It's node 3. The same way, node 3. What is the node that is at east side? It's node 2. What is the point that is at the west side of node 3? It's 4. Node 4. So you write it node 4. After you wrote the equation, then you will write it like a matrix. When you write the matrix, you will convert all of term T to the left hand side equal to the source, because the source will be the B matrix. The B matrix, this is the B matrix, this is the B matrix. And when you convert 0.02 to the left hand side, it will be negative, and so just T1 is equal to positive 0.02016 minus 0.02. I don't have T3 or T4 or T5. The same way for the node 2. Node 1, when I convert it to the left hand side with 0.083, it's convert to node 1 minus 0.02. Node 2 is equal to 0.10048 T2, and node 3 minus 0.08. I don't have T4 or T5 in this. So the same way you can write the wall of the matrix. then you will multiply it by the variable that you want, or multiply by the temperature that you want to find. It is equal to the B matrix. Then we will find the result. The result you can find it by using a scientific calculator or by using any program. Here I use MATLAB. By writing the A matrix and B matrix, I find this result, which it is 97, 97, 98, 99, 99. For who don't know how I get Z, Z is equal to A inverse 1 multiplied by B matrix. And then I will find Z. Thanks for watching. I hope that you have useful from this video.